हाँ ना सर अभी क्लास चल रही है क्या
नहीं एक्चुअली न्यू एडमिशन है फर्स्ट क्लास जैसा कि नंबर से था यू कैन कॉन्टैक्ट टीचर
no sir my your his mentor is Vidyadhar sir no sir
हाँ
he did not make it
हाँ मिला था
हाँ मिला ना
हाँ तो क्या बोले मेरे को एक्चुअली में बायोलॉजी में मिला
हाँ
सुन में मिला
हाँ
आपको तो देख के नंबर कुछ डिफिकल्ट आ रहा है
हाँ okay no problem please हाँ yes yes no no problem
because
Farhan no sir
हाँ
Farhan yes 9686 86 70 9979 9 9686709979 okay yes sir okay sir no yes 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 students please join. Yeah, I hope you can understand now. Yeah, this is fine. Yes. Uh, we are discussing about very important and new chapter. Actually, differentiation chapter somewhat pending is there. That will be again some 2-3 days later, or else after some time. Ram sir will continue. Because of he is not feeling well, I am just starting new chapter integration. Okay. So this is most of the students used to say that sir it's very difficult chapter and it's very hard to do the integration. My dear students, very important thing I want to tell you, if you are very serious about the differentiation, then easily you can do the integration. If you don't do practice properly with the differentiation, then you can't go with integration. Yes? Yeah. Integration. So now I will start new chapter, integrations. Integrations. See, there are two different types of integrals are there. One is one is definite integral, another one is indefinite integral. There are two types of integrals are there. One is a definite, another one is indefinite integral are there. See, actually the integration is nothing but it's a reverse process of differentiation. Integration is nothing but it's a reverse process of differentiation. Integration is nothing but it's a reverse process of differentiation. Yes, now look at this, the reverse process. Simply what I do, if I want to differentiate derivative of x cube, what is the derivative of x cube? It is always 3x square, correct? The derivative of x square is 3x cube is 3x square. Now if I differentiate derivative of x square d by dx, it is 2x. Differentiation of x square is always 2x. and differentiation of x cube is always 3x square. So derivatives, if you know, then very simply, if someone asks you what is the antiderivative of this, easily you can say it is x cube. What is the antiderivative of this 2x? It is, we can call it as x square. So what is the meaning of this? Derivative and antiderivatives are just reverse. See here, you have x cube and its differentiation if you do, it is 3x square, and if you do antiderivative, its value will be x cube. Understand my point? Look at this. It's a very simple. Now, the thing is that, see, when I have a term y equal to x cube plus 1, I take some one functions, x cube plus 1, y equal to x square plus 7, or else x cube plus 7, y equal to x cube plus 100. Understand very properly. I have taken 3 different functions, but the thing is that only the constant term is different. I have taken x cube plus 1, x cube plus 7 and x cube plus 100. Yes? See here, when I take x cube plus 7, x cube plus 1, x cube plus 100, let us differentiate. You can say y dash, derivative of x cube is 3x square and derivative of 1 is 0. Here y dash 3x square and here y dash 3x square. In each case, 1, 7, 100, they are all constant. After differentiation, they can vanish. They will get 0. Yes? So when they get 0, then the functions after differentiation, they are all look same. Correct? They are all look same. But the thing is that when they give a function 3x square, you are going in the reverse order. You don't know which constant was added earlier here it is. Do you know that? 3x square was added here is 1, here it was 7, here it is 100. Simply one constant was there, but they say that you have a function f of x equal to 3x square, find the antiderivative of this one, means integration of this one. And simply what you can do, you will just go with the reverse process. When you do the reverse process, by the time, it's a very important thing you remember, you can get the value of variable only. Understand my point? You will get the value of variable only. Variable if you get, then if you don't get the idea about the constant, simply what we do, say for example, if I want to integrate this, say that is capital F of x, and if I say that it is x cube, I will not get any idea regarding the constant, so I say that it is c. This c we can call it as integration constant. This is what we call integration constant. See, this value is unknown for us. Either it may be 1 or 7 or 100 or some other constant, correct? It may be any value. That's the reason we can call these as indefinite integrals. Not definite, indefinite. Value you don't know perfectly here. You don't know exact value of that function. You don't know exact constant number of that function. So what do you say? You can say it is indefinite integrals. When you say indefinite integrals, then very easily you can say that it is somewhat value is there and somewhat value is there. It may be any one real number. It is somewhat real number. It is correct. Very good. Now the same logic, sin x plus 3, sin x plus 7, sin x plus 8, any number if you take, after differentiation all looks same, means variable looks same, constant vanishes. But when I go with the reverse, I have to add the constant c. Correct? So this reverse process is nothing but, look at this, you have x cube, degree is 3, you have x cube, degree is 3, you have x square, degree is 2. When I do the differentiation, x cube differentiation becomes 3x square, x square differentiation becomes 2x. It means that the term differentiation reduces the degree of the polynomial or degree of the given equation. When it reduces the degree of the polynomial, look at this, it means it is a differentiated, it is a separated the terms. So when it differentiates, now look at this, antiderivative. That is what we call the reverse process. That is what we call integration. is nothing but summing of the functions. Just sum the functions. What do you have to do? Sum the functions. When you do the summations, summing all the functions, so then that is what we call integration. Integrate means it is adding all the functions. It is all nothing but summing all the functions. You have to sum which are all differentiated, which are all separated. When you sum them, the answer what you get, that is your original function. Correct? See, and generally this integration say you have a function f of x, you want to integrate this, you want to find the antiderivatives, that is always given by elongated s. Look at this, it is like this. Simply s is like this. If you just pull on both the sides, elongated s, okay, you can say integration of this function. You can say integration of f of x. When you integrate of this function, no, there must be a variable present with respect to x. This is what we say dx. Say for example, suppose you have a function, you want to differentiate, what do? You say d by dx on both sides. D by dx, if you apply, you say that derivative of function f of x with respect to x. Similarly, you are doing antiderivative, reverse process. What is that? Integration of f of x with respect to x, that is dx. Integration of f of x dx equal to dx. So then when you do this one, when you find the antiderivative, then you get original function which was already differentiated. Correct? Now look at this. See, let us write the definition of this. What is this definition? It is a reverse process of differentiation. It's a reverse process of differentiation. Okay. Now let us listen. Let y equal to f dash of x, or else you can say dy by dx equal to f dash of x be a function if we integrate this, it is denoted by integration of dy by dx with respect to x, which is equal to integration of f of x with respect to x. Now look at this. Simply this can be written as, this is all you are integrating with respect to x. Here you are integrating this with respect to x. What do you get? This is only y. Because earlier it was y and you differentiated, so it becomes dy by dx. Once you go with the antiderivative, what do you get? Y. And then what about this? Integration of f dash of x. Before f dash of x, it was f of x, so it becomes f of x. And also, before differentiating, there may be some constants. You don't know what is that constant? You can say it is c. So y equal to f of x plus c, we can call it as integration of this function, where c is called integration constant. Understand? Where c is called integration constant. Correct? And then f of x, this one, this f dash of x here, this part, what I have taken now, this part is called integrand. Integrand is nothing but which function you are integrating. You are integrating this one, so we can call it as integrand, or else you can say like this. Now let us we say generally integrations are denoted by capital I. I use the symbol notation elongated s, f of x dx. Now look at this. Let us we denote one by one. What are all these? This is notation, and here this f of x it is called integrand. It is called integrand. And what about this dx? It is with respect to x. With respect to what variable you are integrating? You are integrating with respect to the variable x. What about this? It is symbol elongated s. You can say it is elongated yes. Elongated yes. Simply it is summing all the terms. Okay. So elongated yes, f of x dx. Suppose I have a sin x function. Look at this, you have y equal to sin x function. You want to integrate this. What you will do? Simply you apply this notation. What is that? Integration elongated s, y as it is, and dx. Elongated s, this is sin x, and dx. Look at this position. You can say here, I can say here, integration sublime dx. Look at this part. Here, this is the position where you are going to write a function. In this one, you just put. You want to integrate log x, substitute here. You want to dx, e raised to x, put here. You want to integrate x square, put here. You want to integrate cos x, put here. So this system is a default system, fixed notation based. It's a notation. Say for example, I want to integrate a raised to x. So I said that integration of a raised to x with respect to x. A raised to x into dx. And observe here. Every time when I was differentiating, dx was there in the denominator. Dx was there in the denominator. But whenever I am integrating, dx always present in the numerator. Dx always present in the numerator. That you don't forget. Whenever you integrate, dx must be always in the numerator. Dx I am talking. Say for example, you want to integrate 1 by 1 plus x square. See integration symbol. You should not write 1 by dx here. It must be. It is box position. This function. It is default system. That is integration of 1 by 1 plus square into dx. Correct? Yes. I hope you can understand this one. Yes. So yeah. Now look at this very carefully. You have a function, and that you are doing the reverse process of. Okay. Now then, what you have to do here? Here, whenever you are solving the integration problems, there are two very important methods are there. One is summation method, and another one is normal directly antiderivative method. Summation method and antiderivative method. Summation method and antiderivative methods. Antiderivative method means you will recall the formula whatever you studied in the differentiation, and you will write the answer for it. Say for example, derivative of sin x is cos x. Derivative of sin x is cos x. Someone asks you what is the derivative of cos x? Antiderivative of cos x means integration of cos x. Easily you will say that reverse part of that. That is by your derivative method. Antiderivative process will be taken by derivative knowledge. And what is the summation method? There is a formula. But very important thing is that whenever you want to apply that summation method, the terms must be restricted. There must be boundaries. There must be end points. Then only you can do that. Otherwise, you can't do that. It's very difficult, and that is there not for your syllabus. But summation method and antiderivative method both are there for your syllabus. But when you go for definite integrals, next concept, definite integrals, there you are studying about the summation methods. Here in indefinite method, we are solving almost every problems using the method of antiderivative. Okay, so let us make the list of all the formulae, whatever you have studied in the differentiation, just its reverse. Okay, now we write list of formulae. Yeah, list of formulae. Correct. List of formulae. Now I will do list. Okay. See, on the first one, f of x equal to x raised to n, or else directly we write, no problem. Integration of x raised to n dx. First, you have to understand, if you are integrating this function, means you are doing the antiderivative of this function. When you do the differentiation, the degree of each polynomial go on decreases. X cube derivative 3x square. X cube derivative 3x square. Understand very properly. X square derivative 2x. Understand very properly. X square derivative 2x. X cube derivative 3x square. I hope you can understand. Now, when I differentiate x raised to n, what I get? N into x raised to n minus 1. Correct? N into x raised to n minus 1 means 1 degree will be less. Suppose I have x raised to n only. After the differentiation, what may be the degree of this term earlier before the differentiation? 1 degree more. Correct? Suppose I have x square. I want to integrate x square. What is the derivative of, what is the degree of that function before the derivative? X cube. So like that, its value is x raised to n plus 1. What is integration of x raised to n? X raised to n plus 1. And also remember, when I differentiate x raised to n, you write n into x raised to n minus 1. N into x raised to n minus 1. So here, this number should be divided by n plus 1 plus integration constant. Understand very properly. Remember the formula. Integration of x raised to n is x raised to n plus 1 divided by n plus 1. Correct? Second one. Integration of x dx. What is integration of x? X square differentiation becomes x. Now it is x raised to 2 divided by 2. If you don't understand this, simply the power of x is 1 here. Put here. 1 plus 1, 2. 1 plus 1, 2. X square by 2. If you remember this, easily you can write this. Second, third formula. Integration of 1 with respect to x. When you get integration of derivative becomes 1, whose differentiation is 1? X ka differentiation. So that is, it is x plus c. So integration of 1 is always x. Remember, integration of 1 is always x. Okay. So the next one. When I go with yes. Next formula. I have several results, e raised to x, sin x, cos x, tan x, and all that things. Now look at this. Fourth one. Integration of e raised to x dx. This is e raised to x plus c. This is always e raised to x plus c. Because differentiation of e raised to x is e raised to x. But every time I think you have observed, you are observing I am adding plus c. What is the meaning of that? It is some constant. Every indefinite integral is ended with some constant because you don't know earlier, before differentiation, there was a constant present, and what is that? We don't know that. So simply we write it is c. And some students may ask, sir, if I write c, then how we get accurate value? Here, that's the reason integrations are called by name indefinite integrals, not definite, indefinite integrals. Next you will study in the concept definite integral. There you will not get any c, directly the value will get. Okay, so it is called indefinite integral. The next one, fifth, integration of a raised to x dx. You know well, derivative of a raised to x is a raised to x into log a. Here reverse, divided by log a. A raised to x divided by log of a plus c. Correct? A raised to x divided by log a. And the next one, So we can say here integration of sin x dx. It is very difficult because you know that derivative of cos x becomes sin minus sin x, correct? Derivative of cos is minus sin, and derivative of sin x is plus cos x, correct? Now what you have here, sin x means you don't have minus, you have only sin x. When I do the antiderivative of this part, you will get definitely minus cos x here, which is minus cos x plus c. Differentiation of sin x becomes cos x, whereas integration of sin x becomes minus cos x. Once again I repeat, derivative of sin x is cos x, but in case of the integration, sin x still becomes cos, but the sign is minus. Sin x ka derivative becomes minus cos x. Okay. 7th one, integration of cos x dx. Here cos x integration is plus sin x. Understand this. Okay. Plus sin x. 8th one, derivative of tan x is sec square x. So integration of secant square x dx, which is equal to tan x plus c. Understand? I am taking only the standard results whose derivative is known for you. Whose derivative is already we know. Integration of cosec square x. You know very well cot x integration is minus cosec square. But here it is plus cos x square you are taking, so it is minus cot x plus c. Minus cot x plus c. And the 10th one, look at all these things, what I am doing here. And here in everywhere, one thing I think you are observing, I am not using the function sec x, cosec x, cot x, tan x. I hope you can understand. Because tan x is not the derivative of any function. Cot x is not the derivative of any function. It means that they are not the derivative. They are not the derivative of the standard functions. What are the standard functions? Sin, cos, tan, sec, cosec. These are the 6 trigonometric functions. In that, tan x is not directly the derivative of any of the standard function. Cot x is not the derivative of the any standard function. Cosec x is not the derivative of the any standard function. So you cannot go with antiderivative of that part. Yes, only we are doing these as the standard cases. Correct? When you do these as the standard cases, now look at this, and which are all the again standard cases you have studied. Still you will study only this much. These are the standard results. And the next we are studying the problem based on these standard cases. Later on you have a question. Then if sir, integration of tan x comes, then how to do that? It's a very simple. It's very easy. We can call it as, it is called substitution method of integration. We go with some other methods. There are again different methods like differentiation. Here also differentiation, how you apply sum rule, product rule, quotient rule. In integration also we have different rules. That is substitution method, partial fraction method, by parts method. There are several different methods are there to find the integration of the given function. So only these are the cases we have the standard results now. Once if you do this, then first exercise aram we can do, and then we can proceed for the second exercise. For substitution method, you don't know the integration of log x, you don't know the integration of tan, cot, sec, cosec. All these will proceed again in the next exercise. Okay? Yes, we'll finish now. Thank you. I hope you will join again next in this one only, because it is again fine you are getting videos also you can see later. Okay? Yes, done.